Every app project begins at a junction. You can build two entirely separate native apps for iOS and Android, or you can build one hybrid app that runs on both platforms from a single codebase. The financial stakes are high. Picking the wrong path frequently wastes 40% of a development budget, or results in an app that fails to perform on the target hardware. This creates a central dilemma. Are modern hybrid architectures truly near-native, as the marketing suggests? Or are they just a compromised, clunky wrapper around web code? We are going to look past the hype to determine the exact business use cases where hybrid works and where it fails. Success depends on prioritizing your specific business constraints and budget over absolute technological perfection. We can map every project using two variables: hardware reliance on the x-axis and budget constraints on the y. High-complexity apps with low budgets, like 3D games or AR tools, fall into the bottom right. This is a danger zone where the technical requirements often exceed the available capital. Standard utility apps, like e-commerce or B2B tools, sit in the top left. They face high pressure for a fast launch, but require relatively low hardware complexity. The gap between these two extremes is massive, and your choice of architecture is what bridges that distance. There is no single best way to build. There's only the mathematically correct match for your specific coordinates on this chart. Hybrid development uses frameworks like React Native or Flutter to create a single codebase that runs on both Apple and Google devices. Because one team builds both versions simultaneously, you can reduce development time and save up to 40% in upfront labor costs. To get those savings, you sacrifice platform-specific native optimization. This visual shows the mechanical difference. On the left, native code speaks directly to the processor. On the right, hybrid code must pass through a translation layer before the hardware can execute it. This creates noticeable lag in graphic-heavy apps, specifically during complex transitions or high frame rate animations. Upfront budget savings are only a victory if your core features don't require peak processing power. Hybrid apps rely on third-party plugins to access native features like cameras, sensors, or GPS. This allows for rapid integration of standard hardware without the need for specialized iOS or Android experts on every project. This chart shows the primary bottleneck. The plugin layer creates a strict dependency on outside framework updates. When Apple or Google release a new OS feature, your app is effectively locked out until the community or framework maintainers update the relevant plugin. If your strategy requires being first to market with cutting-edge hardware integrations, a hybrid architecture is a liability. Hybrid frameworks enforce a unified design across all target operating systems. This results in strict brand consistency, ensuring the user journey is identical whether the customer uses an iPhone or an Android. However, this forces you to bypass the platform-specific UI behaviors that users subconsciously expect from their devices. You lose native gestures like the swipe to go back on iOS or standard Android date pickers, replacing them with generic versions. This subtle friction matters significantly more for B2C apps, where retention is everything, compared to B2B enterprise tools, where utility is the priority. Unified design saves design resources, but requires you to provide a non-native interface to highly habituated users. Post-launch, you manage all maintenance and updates through that single shared codebase. Daily operations are simpler, because a single bug fix deploys to all platforms simultaneously. But upgrading the core framework itself can occasionally break cross-platform compatibility unexpectedly. As this model shows, a major update shifts the debugging burden from an isolated platform fix into a holistic cross-system crisis. Day-to-day maintenance is significantly cheaper, but major framework version updates introduce systemic risk to the entire app. Hybrid apps are powerful tools for efficiency, but they are not built for absolute performance maximization. To choose your path, start with this question. Does your app require heavy 3D rendering or niche hardware integration? If you are building high frame rate mobile games or AR/VR solutions, you belong on the hardware path. You must build native. If your focus is utility, like a startup MVP needing rapid time to market, hybrid is your ideal candidate. E-commerce and retail brands, where the core functions are browsing content, syncing carts, and secure payments, also benefit most from the hybrid approach. Finally, enterprise companies needing internal tools that work across many different device types should prioritize the efficiency of a shared codebase. Paying double the development costs for processing performance your app never actually uses is a waste of capital, often called the native tax. For business applications in commerce, operations, and utility, hybrid development is a mathematically sound, strategic path. Avoid the hybrid path only if your core value depends on edge case hardware or high-intensity graphics. The right architecture choice aligns your technical capabilities with your available budget and the specific expectations of your target audience.